Hi, and welcome to this channel. Today, I'm going to talk about the robust optimality analysis of non-degenerate basic feasible solutions in linear programming problems with fuzzy objective coefficients. My name is Pablo Emmanuel Londoño Melo. Well, before starting to break down the article, it's necessary to explain some concepts in order to understand it, with the definitions of each of the elements to be discussed in this wonderful world of optimizing solutions in linear programming problems with fuzzy objective coefficients. What is a linear programming? Linear programming is a mathematical optimization technique used to solve problems that seek to find the best possible value of a linear objective function, subject to a set of a linear restriction. This is very important. The objective function is a mathematical expression that you want to maximize or minimize and represent limitations on the decision variables that must be met. What is the objective? Well, the objective of linear programming is to find the optimal combination of decision variables that maximize or minimize the objective function, simultaneously satisfying all established constraints. What is an objective function? In a linear programming problem, the objective function is a mathematical expression that must be maximized or minimized. It represents the objective or criterion that is sought to be optimized. It's generally composed of decision variables and coefficients that weigh the contribution of each variable to the final result. What is a restrictions? Constraining are the limitations or conditions that the decision variables must meet in a linear programming problem. These limitations can be represented by equations or inequalities and define the feasible space of solutions. Objective function coefficients. They're the numerical values that multiply the decision variables in the objective function. These coefficients indicate the relative importance of each variable in the optimization objective, whether to maximize or minimize. Well, necessarily optimal solution. A solution that is necessarily optimal is one that is the most reasonable or favorable in linear programming problems with intercalary or fuzzy objective function coefficients. This solution maintains its quality even in the presence of fluctuations in the objective function coefficients. Basic feasible non-degenerate solution. In linear programming, a non-degenerate basic feasible solution is a solution that satisfies all constraints and has a minimum numbers of non-zero variables. Non-degenerate means that the constraints are neither redundant nor existent. Well, linear programming problems with fuzzy objective coefficients. They're a type of optimization problem in which the coefficients of the objective function, that is, the values that weigh the decision variables to maximize or minimize, are subject to some vagueness or uncertainty. Vagueness is represented by fuzzy sets, which allow for the gradual inclusion of elements rather than simple belonging or not belonging. Why fuzzy? Well, in the context, fuzzy refers to the imprecise nature of the coefficients to the objective function. Instead of having exact deterministic values, coefficients can vary within a possible range due to uncertainty, data variability, or lack of precise information. This variability is handled using fuzzy set theory. Fuzzy objective coefficients in linear programming. The introduction of fuzzy objective coefficients in linear programming adds a new level of complexity and release to the result optimization problems. By considering the vagueness and uncertainty in the values of the objective function, the nature of decision in context where information is incomplete or variant is more accurately reflected. This, in turn, requires to use a tools such as fused theory to address problems more realistic and effectively. Conclusion. In summary, linear programming emerged as a variables to and versatile tools in optimizing wide variable of real-world situation through the formulation of an objective function and constraints. This mathematical approach allows informed and efficient decision making, maximizing benefits or minimizing cost while meeting certain limitations. Linear programming finds applications in fields as diverse as manufacturing, logistic, financial investment, resource management, and many other areas. Thank you so much.